Hello pre-calc students. Today I'm doing the solution key to the Common Assessment 1 study guide. Hopefully this will help you be successful on your Common Assessment this Monday. Alright, first question is of the 12 parent functions, which functions have a range of all real numbers? And so I'm just going to list the parent functions and draw them and for each category. So parent function with a range of all real numbers, that is functions which ranges from negative infinity to positive infinity. All right. Those are going to be the identity functions. The identity function. So you have the identity function. The identity function uses the function y equals x. So looks like that. You also have the cubic function. Cubic, y is equal to x cubed. The function has kind of that behavior. And then you have the natural logarithm function. So the natural logarithm and this is y is equal to the log base e of x, or is equal to the ln of x. And this function looks somewhat like this. And drawing the x-axis, that would be the x and y axis. That would be the y-axis right there. So that's the natural log function. Now let's move on to functions of the domain of all real numbers. So that is going to be, once again, the identity function. In addition to the identity function, the quadratic function is included. In addition to the quadratic function, there is the cubic function. In addition to the cubic function, there is the absolute value function. In addition to the absolute value function, there is the sine, cosine, logistic. Sine, cosine, and logistic. The formula for the identity function is, once again, y is equal to x. The quadratic function is y is equal to x squared. The cubic function is y is equal to x cubed. The absolute value function is y is equal to the absolute value of x. For a sine function, the function can be viewed as y is equal to the sine of x. The cosine function, y is equal to the cosine of x. The logistic function, you have different forms of it, but it's usually 1 over 1 plus e to the negative x. Okay, now as far as the graph shapes go, identity function is going to look like how we've already drawn it. Quadratic function is a parabola. Cubic function looks like such. Absolute value function is a V with a vertex at the center. The sine function is going to increase and decrease. So you start at the middle, then at the quarter point you hit a maximum, then you hit a middle at the halfway point of the period, then you hit a minimum at a 3/4 of the way, and you end back in the middle. For the cosine function, you start at a maximum, quarter way through your period, you are at a midpoint, halfway through the period, you are at your minimum, and 3/4 of the way through your period, you're at a midline, and then when you finish the period, you're at your maximum, and these repeat. Right, so the same process repeats over and over again. Logistic function has a lower bound horizontal asymptote, and then it starts to curve up like an exponential function, hits an inflection point, starts to increase slower like a logarithmic function, and then hits a horizontal asymptote at the top. So logistic functions have a horizontal asymptote at the top and the bottom. All right. So now that was domain of all real numbers and range of all real numbers. Now looking at functions that are bounded. The bounded functions, they're bounded from both the top and the bottom, are the logistic, sine, and cosine. So the logistic function bounded from both the top and the bottom. This is the logistic function is bounded. The sine function is also bounded. Bound from the top and bottom, the sine function does and the cosine function additionally, starting at the top and going down and going back up. The cosine function are all bounded from the top and the bottom. So the sine and the cosine function. Bounded from above, no functions are bounded from the, no parent functions are bounded from above. So no parent functions are bounded from above. Bounded from below are the quadratic and absolute value functions. So the quadratic function has a minimum below the vertex, so it is bounded from below. And the absolute value function is also bounded from below. Absolute value function. Now, unbounded functions are the rational function. So you have the rational function, rational function is y is equal to 1 over x, and the rational function looks something like this. You have decreasing behavior, so drawing your xy axis. The rational function gets smaller and smaller like that, and then it decreases like this. So that is your rational function. And additional to your rational function, you have the greatest integer function. So greatest integer, it's called the greatest integer slash greatest integer slash floor function. And the idea with the greatest integer slash floor function is that you take your input and you find the greatest integer. So the graph does look somewhat like this. And it continues on in all directions, where you plug in your input and the output is the greatest integer. Alright, in addition to the greatest integer function, there is the cubic function. We've already seen that. Cubic, and by the way, we usually use that terminology for our greatest integer function. Y is equal to the greatest integer of x, the cubic function. Looks like that. And then the identity function looks like this. And natural logarithm, y is equal to the ln of x, and this function looks like that. It's a little bit, so I'm going to try to improve my handwriting. That's okay. Now we're going to move to question 3. The function f of x is equal to 3 of x was replaced with 2 times the f of x minus k, resulting in a function shown in the table below. What is the value of k? So what I'm going to do is analyze something. What if we had our original function is 2 times the f of x is equal to 3 to the x. So if f of x is equal to 3 to the x, 2 times f of x is equal to 2 times 3 to the x. So let's analyze this function. 2 times 3 to the x power. All right, and let's look at our table here. This table should make sense. Well, let's look at 0, 1, 2, 3. Let's look at 0. When x is 0, that's 2 times 3 to the 0. Well, 3 to the 0 is 1. So when x is 0, y is 2 times 3 to the 0. That's 2 times 1, so that's equal to 2. When x is 1, 2 times 3 to the 1 is 2 times 3, which is 6. All right, and then so on and so forth. Hopefully you can see with your calculator that you can take your calculator, find the function, and use your calculator's table to find the inputs and the outputs to produce an output of 18, and 3 produce an output of 54. But now we have this downward shift minus k. And the whole idea here is that to get to our table, we need to go from 2 to negative 3, 6 to 1, 18 to 13, 54 to 49. And in order to do this, we have to subtract a number. We have to subtract positive 5. 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 In all these situations, our original output, 2 times 3 to the x, which we are given, we have to subtract 5 in order to get to our given table here. So because of that, we find that 2 times 3 to the x minus 5 will produce this table. All right? So this is, long story short, you have to subtract positive 5. So k is equal to positive 5. Okay. What transformations to the graph y is equal to x squared are made when y is equal to negative 4x minus 12 squared plus 3 is graphed? Okay, so what our goal here is to first factor out our equation and then figure out what our transformations are. So first we need to factor out equation. So first of all, I transform this equation to y is equal to negative, and then they always say negative, and I factor out what's in the parentheses, 4, and when I factor out a 4, what is left is a x minus 3. And the whole thing, the whole item is squared plus 3. And now we have to analyze. Let's look back at our transformation equation. Plus or minus a times f of plus or minus b times x minus h plus k. All right, and let's look at all of our transformations. If our coefficient a is positive, there's no reflection across the x-axis. But if your coefficient for a is negative, there is an x-axis reflection. So this negative sign for your coefficient outside the function indicates an x-axis reflection. And that exists in our function. So this is, and that negative sign right there. Let me undo that so you can see it more clearly. But that negative sign does indicate an x-axis reflection. All right. Now, we also have our a term. Now, there is no a term because that's minus 1 if you really think about it. So there's no horizontal or vertical there's no vertical stretch or shrink. Now looking at our b term. Our b term is positive when you factor out b. And because that b term is positive, that means there's no y-axis reflection. So there's no vertical stretch or shrink, and there's no y-axis reflection. If that 4 was negative, there would be a y-axis reflection. That 4 means that there is a horizontal shrink horizontal compression, I should say, a horizontal compression. There is a horizontal compression by a factor of 1/4. All right. Now, then you have a shift, right 3. So notice, for your b term, if the absolute value of b is greater than 1, you have a horizontal compression, by 1/b. If the absolute value of b is greater than 0 but less than 1, aka a fraction in between 0 and 1, will have a horizontal stretch by 1 over b. Okay? So we have a horizontal compression, because 4 is greater than 1, by 1/4. Now, we're going to shift. H indicates our horizontal shift, and so we just look at x minus 3. We do the opposite when we're inside the parentheses, so that's going to be a shift right 3. So that's a shift right 3. And outside of the parentheses, that is a shift up 3. So our transformations are, we have a reflection across the x-axis, a horizontal compression by a factor of 1/4, a shift right 3, and a shift up 3. But first we have to be able to factor out what is inside the parentheses and analyze our function using the function transformation equation cheat sheet. Okay, let's move to problem 5. Determine the end behavior of the function y is equal to negative 3x times x minus 3 squared times x minus 2 cubed times x plus 1. And the best way I'm going to do this is to use my calculator. I'll take my calculator and I'm going to, step 1, I plug the function into calculator, plug the function into my calculator. So plug it in. Y is equal to negative 3x times x minus 3 squared times x minus 2 cubed times x plus 1. All right. And then at this point, I can try graphing it, but it's going to be a little bit hard to see what's going on. It's hard to see. It's really hard to see. So to find end behavior, I'm going to go to my second table set, okay? I'm going to, end behavior, if you really think about it, is the value or the limit when x approaches negative infinity of f of x, and the limit when x approaches positive infinity of f of x. So while we can't have our calculator evaluate when x is equal to infinity, we can have our calculator approach when x approaches negative infinity and positive infinity, and we can do that by analyzing the function at really small and really big numbers. So let's analyze the function at a really small, or I should say, really large negative number and a really large positive number. So let's look at the table when we start at negative 9999999, okay? Analyze your table, second graph that moves it to its table. This is when x is a really large negative number. What that means is y is equal to e times 3 times 10 to the 49th, which is an incredibly large number. Positive e 3 times 10 to the 49th. So that's approaching infinity as x approaches negative infinity. Okay? And I understand this because when x equals negative 9999999, y is equal to 3 times 10 to the 49th. Now, if x is equal to positive 99999, so a really big number. 99,999. We go to our table. Once again, when x is equal to 99999, Herman Cain, hashtag, y is once again equal to -3 times 10 to the 35. So a negative number that's really big. So that means f of x is going to be approaching negative infinity as x approaches infinity. So notice as x is a really small negative number, y is a really large negative number. So x is a really large negative number, y is a really large positive number, and x is a really large positive number, y is a really large negative number. You can also figure out that here our leading coefficient is -3. So our leading coefficient is -3. Main importance is that it is negative. And our highest degree here is odd, because if we multiply this out, our highest degree should be odd. And because of that, that degree should be odd for this polynomial. So, but to be safe, I would use our calculator. And do your test in your calculator. All right. Given the piecewise function shown below, so anyways, yes, this is our end behavior. X is equal to, the limit as x approaches negative infinity of f of x is infinity. The limit as x approaches infinity of f of x is negative infinity. And it will be hard to see, so maybe you can you can zoom out or change your window so that your y min becomes, I don't know, negative 1,000, and your y max would become 1,000. Graph in this function. Yeah, that gives you a good view. When you change the window, what does this function look like? Function looks like, looks like that. So it has that end behavior. All right, given the piecewise shown below, find the value of h of 2 minus h of -3 plus 3h of -2. So let's first, I'm going to analyze h of 2, h of -3, and then 3 times h of -2, and then add them up. So first, h of 2. 2 is not less than or equal to -3. 2 is not greater than -3 or less than or equal to 1. 2 is greater than 1. So we're going to be choosing formula between 1, 2, and 3. We're going to be choosing formula 3. So you're choosing formula 3. So that's going to be -2 cubed minus 4. All right, so -2 cubed minus 4, that becomes -2 cubed is 8, 2 times 2 times 2 is 8, minus 4 is -12. So h of 2 is -12. We're gonna keep that in mind there. We're gonna keep that in mind. Keep it as a placeholder. Let's find h of -3. H of -3. Well, -3 is less than or equal to -3 because -3 is equal to -3. So we're going to plug it into this equation. This will be equal to 2 times -3 plus 9 over 5. So that's going to be -6 plus 9 over 5, which is equal to -6 plus 9 over 5. And -6 plus 9 is 3, so that's going to be equal to 3/5. And our last thing to analyze is that uh, 3, let's just find h of negative 2 here. H of negative 2 is equal to, well, negative 2 is not less than or equal to negative 3. Negative 2 is not greater than 1. Negative 2 is greater than negative 3, but less than 1. So we're going to plug it into the second equation. So negative 2 is going to be equal to 3 times the absolute value of negative 2 plus 1, because you're plugging negative 2 into the equation, minus 2. And that will simplify to 3 times the absolute value of negative 2 plus 1 is negative 1. 3 times the absolute value of negative 1 plus 1. And the absolute value of negative 1 is the function, the number's distance from 0. So the distance from 0, negative 1's distance from 0 is 1. So that becomes 3 times 1. So that becomes 3 times 1 plus 1, so that's going to be equal to 4. So this is equal to 3 times 1, the absolute value of 1 is 1, plus 1, which is equal to 4. So now we have h of negative 2 is 4, so let's get this down. H of 2, we just worked out, is negative 12. H of negative 3 is 3/5. And h of negative 2 is 4. So let's add this up, okay? Oh, that's minus 2. X plus 1 minus 2. So here, mistake here. 3 of this is going to be 3 times the absolute value of negative 1 minus 2. So that's equal to 3 minus 2, which is equal to 1. So this is equal to 1, which means that h of 2, I can get rid of this, this will be equal to 4. Sorry, so h of 2 is not equal to 4, it's equal to 1. So h of 2 is negative 12 minus h of negative 3. That's equal to 3/5. So that's negative 12 minus 3/5 plus 3 times h of 2, which is 1. So that's 3 times 1, so that's just 3. So that's going to be equal to negative 12 plus 3 is negative 9. So will be equal to negative 9 minus 3/5. So that will just be equal to negative 9 and 3/5. You could also say 9 times 5 is 45. So this could also be equal to negative 48/5. These are both correct solutions. So that is evaluating the piecewise function. You just have to be methodical and plug things into the function. Furthermore, you want to make sure that you're careful. So I made a quick mistake. I didn't evaluate that negative 2. I forgot about it when I carried things over. So, it's okay to make mistakes, but one way to really show that you know what's going on is if you can catch yourself making this mistake, then that shows you that you're checking your work. Algebraically determine whether the function below is even, odd, or neither, and explain why f of x is equal to x to the 5th times the square root of 2x plus 1. All right, so as an overview, even functions, f of negative x is equal to f of x. This is an even function. and f of negative x is equal to negative f of x. That is an odd function. So those are the rules for an even function and an odd function. So let's evaluate. This is equal to f. So we have f of x. Now let's find f of negative x. F of negative x is equal to negative x to the fifth times the square root of 2 times negative x plus 1. All right, and so this will be equal to negative x to the fifth times the square root of negative 2x plus 1. And first of all, I see that this term is not equal to f of x. So because this f of negative x, this does not equal f of x. I mean, this does not equal x to the fifth times the square root of 2x plus 1. This does not equal f of x. If it does not equal f of x, if f of negative x does not equal f of x, then f of x is not even, okay? So we can eliminate the function being even here. Now let's find negative f of x. Negative f of x is now we take f of x and we multiply it by negative 1. We take f of x, we multiply it by negative 1. So that is just negative x to the fifth times the square root of 2x plus 1. So that's just going to look like negative x to the fifth times the square root of 2x plus 1. And so this, what this equals, f of negative x, also does not equal negative f of x. It just doesn't, because you don't have that 2 times negative x. You don't have any negative term inside the square root. Furthermore, so we know it's not odd, so we know it's neither. Furthermore, let's just graph this function. I'm going to take my function, if I can get my calculator to turn on here, and find x to the fifth times the square root of 2x plus 1. All right, and now I'm going to look at the table here. All right, I'm going to change. Well, first I'm going to change my table set so that I start at 0 again. Now I'm going to look at my table here. Let's look at my values here. You don't have symmetry here. You don't have it where your positive x input is equal to, for example, when your x input is 1 and the output is 1.73. If this function was even when the input was negative 1, the output would also be 1.73. And if the function was odd, the output would be negative 1.73. But you don't even have an output here. So you can't have symmetry. Furthermore, just graphing this function, you do not have symmetry across the origin and you don't have symmetry across the y-axis. Just from right there, you don't have symmetry across the origin. You don't have symmetry across the y-axis. So not even or odd. Okay, so the answer is neither. F of negative x does not equal f of x. F of negative x does not equal negative f of x. No symmetry. No symmetry at all. Okay. 8. If p of x is equal to x minus 3 and k of x is equal to 4 minus x, find the domain of k of x over p of x. All right, so let's find k of x over p of x. You find this. Let's draw here. All right, k of x is equal to the square root of 4 minus x, and p of x is equal to x minus 3. Now, there's two situations here where we have a restricted domain. We have a restricted domain when dividing by 0 and taking the even root of a negative number. Taking the even root of a negative number creates an imaginary number, which is not in the domain of all real numbers. Because of that, we have the square root of 4 minus x over x minus 3. We have to look at both domain restrictions. You cannot take the root of an even root of a negative number. So 4 minus x is the term under the root. This has to be positive, or cannot be negative. So because this term cannot be negative, that means that 4 minus x has to be greater than or equal to 0. If x meets this test, then that means that negative x has to be greater than or equal to negative 4, which means that, and now we divide each side, so this part I just subtracted 4 from each side, by the way. And now I'm dividing each side by negative 1, and each time you divide by negative 1, you flip your inequality. So x is less than or equal to negative 4 divided by negative 1 is positive 4. So x is less than or equal to positive 4. That is one inequality I have to deal with. Another restriction I have to deal with is that my denominator, cannot equal to 0. So x minus 3 cannot equal 0. So this term can't equal 0. So that cannot equal 0. So that sets up the equation x minus 3 cannot equal 0. If x minus 3 cannot equal 0, that means x cannot be equal to 3. All right? So in order to find the domain, we have to respect both this inequality and this restriction. We have to respect both restrictions. So we have to respect x is less than or equal to negative 4 and x cannot equal 3. And the reason for this is that if you respect one but not the other, you have a domain restriction. You still have an area where you're not in the domain. So let's draw the number line. We have 4 and 3. These are critical values. X can, under 1, x has to be less than or equal to negative 4. X can equal 4 and can be anything less than 4. But under this restriction, x cannot equal 3. So you have all values except for 3, then x can be equal to. So what is our domain restriction? Well, any value below 3, we are fine. So for our domain, we can have any values that go from negative infinity to 3. 3 is not inclusive. And the reason why 3 is not inclusive is because we can go up and approach 3, but we can't equal 3. Then I have a union, and then we can also have a domain from 3, once again not inclusive. So we have this interval, and we can go from 3 not inclusive, we can't touch 3, all the way up to 4. And we can equal 4, so I'm going to have a bracket instead of parentheses, but I can't go past it. So that is our domain. And here we go. That's the answer to 8. Now, for 9, given t of x is equal to 3 minus 5x and p of x is equal to 2x minus 7, what is the value of p of t of 3 minus t of p of negative 3? So what we need to do here is take our composition. All right, so let's find p of t of 3. Well, let's find p of t of x. Well, p of t of x, that is equal to p of t of x. We have to plug t of x into p of x. So t of x is 3 minus 5x, and p of x is equal to 2x minus 7. We just plug t of x into p of x. So p of x will be 2 times 3 minus 5x minus 7. This will become 6 minus 10x minus 7, and 6 minus 7 is negative 1. So this will become negative 10x and then negative 7 minus 1. So that's p of t of x. That's equal to negative 10x minus 1. Now let's find t of p of x. So t of p of x is equal to, well, p of x is 2x minus 7. We plug in the t of x is 3 minus 5x. That's become 3 minus 5 times, now we plug p of x in, 2x minus 7. So this becomes equal to 3 minus 5 times 2x is 10x. 5 times negative 7 is negative 35. So 3, so that's going to become equal to negative 10x. Negative 35 plus 3 is going to be minus 32. So now we need to evaluate p of t of 3. So if p of t of x is negative 10x minus 1, p of t of 3 is going to be equal to negative 10 times 3 minus 1. So that's going to be equal to negative 10 times 3, that's negative 30, minus 1, that's equal to negative 31. And t of p of x, well, p of x, we'll need to find p of negative 3. So p of negative 3, that's going to be equal to, plug in negative 3. That's going to be equal to, plug in, so t of p of negative 3 is going to be equal to negative 10 times negative 3 minus 32. So negative 10 times negative 3 is positive 30 minus 32. That's equal to negative 2. Let me check this out again. So p of, this becomes negative 10x minus 32. So it becomes 30 minus, it becomes negative 32. And then I'm gonna just, the answer keeps showing something different, so I'm gonna double check my work. P of x is 2x minus 7. Plug that into t of x. That is going to be 3 minus 5. That's 2x minus 7, so that's going to be 3. So that's 3, okay, right, it's 3 minus 5 times 2x minus 7 is 10x minus 35. So 3 minus negative 35 is going to be negative 10x. And 3, that's going to be 3 plus 35. So that's going to be plus 38. So that's going to be negative 10 times negative 3 plus 38. Which is equal to negative. That's going to be equal to 10 times negative 3 is negative 30, plus 38 is going to be 68. So negative 30 plus 38 is going to be equal to 68. Then what I do is, so I say t of p of negative 3, that's equal to 68. So then I have negative 31 minus positive 68. And that's going to be equal to negative 99. All right, so that's all the work shown for number 9. 10. If the function g of x is equal to 2 times the absolute value of 2x is reflected across the x-axis and shifted right 4 units, what is the resulting function g of x? So we have absolute value of 2x. All right, I'm going to turn this into notation, the absolute value of 2 times x plus, or x plus 0. So that's the same thing, but I'm factoring out that 2. Now, to reflect across the x-axis for my transformation, I have to have a negative sign outside the function. And to shift right 4, I have to have x minus 4. So g of x would be equal to negative 2x minus 4. That once I factor, that shows the x-axis reflection, x-axis reflection, and this value shows minus 4, that shift right 4. Okay. All right, and so that's why your new function is going to be negative. So you have negative times the absolute value of 2 times x minus 4. If you want to distribute that, that's become negative times the absolute value of 2x minus 8. All right, so the answer here would be g of x is equal to negative times a negative sign outside the absolute value of 2x minus 8. 2x minus 8, and close the absolute value, and that's your solution. What is the domain of the function f of g of x when g of x is equal to x minus 4 and f of x is equal to x over x squared minus 16? Well, to find f of g of x, we have to take g of x and plug it into f of x. So that's going to become x minus 4 over, plug in g of x every time there's an x minus 4 squared minus 16. So that's going to be equal to x minus 4 over x squared. 2 times negative 4 is negative 8 times x is x. X squared minus 8x, and negative 4 squared is 16, plus 16 minus 16. So that's going to become x minus 4 over x squared minus 8x. And what I'm going to have to do is look at the denominator and see if I can factor, which I can. That's going to be equal to x minus 4 over, factor out an x, and how left over is x minus 8, because when x squared divided by x is x, and negative 8x divided by x is negative 8. So I have x minus 4 over x minus 8. What I now need to do is, for domain, remember the denominator cannot equal 0, so x times x minus 8 cannot equal 0. So let's analyze 1. X cannot equal 0, and also x minus 8 cannot equal 0. So if x minus 8 cannot equal 0, x cannot equal 8. So if x cannot equal 8 and x cannot equal 0, these are our two domain restrictions. From our two domain restrictions, we can create our domain of negative infinity to 0 union 0 to 8 union 8 to infinity. 0 to 8 union 8 to infinity. Okay, and so that is our domain. All right. 12. The function f of x is equal to x squared plus 7. Is the function f of x equal to x squared plus 7 1 to 1? So this is a quadratic function. This is 7. This is a quadratic function. Is the function 1 to 1? Well, how do we test if the function is 1 to 1? A function is 1 to 1 if it passes the horizontal line test. Does the function pass the horizontal line test? No, it does not. Fails the horizontal line test. And because the function fails the horizontal line test, that means the function is not 1 to 1, and it fails the horizontal line test because a horizontal line can pass through the function and touch it more than one place. Because the function fails the horizontal line test and is not 1 to 1, that also means that the function with no domain restrictions is not an inverse. So is the inverse of the function a function with no domain restrictions? So that just means the inverse of the function. So the inverse, my God. The inverse of the function is not a function if the function is currently failing the horizontal line test. The function is not a function. But the original function does pass the vertical line test. So is the function 1 to 1? 1 to 1? No. Does it pass the horizontal line test? No. Does the quadratic function pass the vertical line test? Yes, it's a function. So it does pass the vertical line test. Yes. Is the inverse of f of x a function? And that's with no domain restrictions. No domain restrictions. The answer is no. You would have to restrict the domain in order to make the inverse a function. All right. Mr. Law's happiness is a function of how many net cookies he sells. modeled by g of x is equal to x minus 5 to the fourth power plus 2 over 6. By the way, this function makes no sense in regards to the concept of the problem. I'm just kind of messing with you guys. What is the inverse of g of x? So to find the inverse, we need to switch x and y. So replace g of x with x. X is equal to y minus 5 to the fourth power plus 2 over 6. Multiply each. So now I try to isolate my y term. So multiply each side by 6. 6x is equal to y minus 5 to the fourth power plus 2. Subtract 2. 6x minus 2 is equal to y minus 5 to the fourth power. Take the fourth root of each side. The fourth root of 6x minus 2 is equal to y minus 5. And my last step is to add 5 to each side. So the fourth root of 6x minus 2 plus 5 is equal to y. Okay, that's our inverse, and so we finally actually would say the inverse. So actually that's the inverse of g of x. So g raised to the negative 1 of x, that's the notation. Let's make that g raised to the negative 1 of x. G raised to the negative 1 of x is equal to the fourth root of 6x minus 2 plus 5. That is the inverse of the function. All right, f of x is equal to 2x minus k. G of x is equal to 3x plus 1 over 2. What value of k makes f of g of x equal to g of f of x? All right. F of g of x is equal to g of f of x. So we need to find f of g of x and g of f of x. F of g of x is going to be, we plug in g of f of x into f of x. So we find 2 times 3x plus 1 over 2 minus k. So that's f of g of x. This is f of g of x. And this is set equal to g of f of x. So that's going to be equal to g of f of x. G of f of x. That's going to be equal to, you plug in f of x and g of x, so that's going to be equal to 3 times 2x minus k all over 2. And so we need to make these terms equivalent. So first of all, what I see is that these 2's cancel out. Times 2 divided by 2. I see that these cancel. This becomes 3x plus 1 minus k is equal to 3 times 2x minus k all over 2. And I'm going to multiply each side by 2 because I need to get rid of that denominator. Multiply the whole side by 2. So I'm going to get left over is 6x plus 2 minus 2k is equal to, I'm going to distribute that 3. 6x minus 3k. All right. Now, I'm going to move over to the other side. I'm going to add 3k to each side. So when I add 3k to each side, I will get 6x plus 2 plus k, because I added 3k to each side, cancels out on the right side. Negative 2k plus 3k is 1k. And that is equal to 6x. And I subtract 6x from each side. The 6x's cancel out. And so I have 2 plus k is equal to 0. And my last stop is that k should be equal to, wait. When I made a mistake somewhere, so let's catch the mistake. If you can catch yourself making a mistake, that will help you do well in tests. So 3x plus 1 minus k. 6x plus 2 minus... Oh, okay, there's a plus 1 here. So this is 3 times 2x plus minus k plus 1. Plus 1. So because there is a plus 1 here, I have 3x, 6x minus 3k plus 1. So I did not add, what I originally did is I did not add this plus 1 here. So I need to make sure I copy the problem right. So that means this is equal to 6x plus, after I subtract add 3k to each side, I will still have 6x. So this will just be equal to 1. This will be equal to 6x plus 1, which means 2 plus k will be equal to 1, which means I subtract 2 on each side, and k will be equal to 1 minus 2 is negative 1. So k will be equal to negative 1 here. For what value of k is the piecewise function continuous? All right, so in order for piecewise functions to be continuous, they need to have the same y value at the interval where the x values meet. So continuous, you need to have the same output value at the interval where the x values meet. So that's what's going on conceptually. What's going on in actuality is that you just have x minus 1 has to be equal to negative 3x plus 4k when x is equal to 3. So I will have, if x is equal to 3, I will have 3 minus 1 is equal to negative 3 times 3 plus 4k. That's going to be equal to 3 minus 1. That's going to be 2 is equal to negative 3 times 3. That's negative 9 plus 4k. Negative 9 plus 4k. That's going to be equal to we're going to have to add 9 to each side. So if I add 9 to each side, that's going to be 9 is equal to 4k. So I divide each side by 4. And k is equal to... wait. So, by the way, 9 plus 2 is not 9. 9 plus 2 is 11. So 9 plus 2 plus 9 is 11. So you have 11 fourths divided by 4. So k is equal to 11 fourths. And 11 fourths is the value of k that will make the piecewise function continuous. All right. 16. Find f of x plus h times f of x minus h over h if f of x is equal to 3x squared plus 2. So all you need to find f of x plus h plus f of x minus h all over h. If f of x is equal to 3x squared plus 2. Now, all right, so we need to actually evaluate f of x plus h and f of x minus h. So this is going to become f of x plus h f of x plus h is equal to 3 times x plus h squared plus 2. So that's going to become equal to 3 times x plus h squared. That's become x squared plus 2hx plus 2hx. 2 times h times x is 2hx plus h squared plus 2. So that's going to be equal to 3x squared plus 6hx plus h squared plus 2. And f of x minus h is equal to 3 times x minus h squared plus 2, which is equal to 3 times x squared. 2 times negative h times x is minus 2hx plus h squared plus 2, which will equal to, distribute that 3x squared minus 6hx plus h squared plus 2. So now I have f of x plus h plus f of x minus h all over h. So that's going to become 3. So we've completely distributed and expanded f of x plus h and f of x minus h. So we're going to have 3x squared plus 6hx plus h squared plus 2 plus 3x squared minus 6hx plus h squared plus 2 all over h. So that's f of x plus h plus f of x minus h all over h. And I can combine 3x squared and 3x squared. Those are terms I combine. First terms I combine, oh, sorry, and that's 3h squared. 3h squared. I can combine 3h squared and 3h squared. Where is... What happened? What happened to my work? Okay, there we go. I can combine 3h squared and 3h squared. 6hx and negative 6hx, these will actually cancel out. And then combine 2 and 2. So that will be equal to, I can also combine 2 and 2. So that's going to become 6x squared, 3x squared plus 3x squared, 6x squared, plus 6h squared plus 4 all over h. And that's what this is in simplest form. Okay. For 17, write a piecewise function with a closed circle at the right end of the leftmost function. So we have a closed circle here and an open circle at the beginning of the rightmost function. So this is the rightmost function. There's an open circle here. All right, so hopefully you can see you have 0, 0, negative 1, 1, negative 2, 4. That this function is f of x is equal to x squared. So this is this function is y equals x squared. That's this parabolic function. And this linear function is the identity function y equals x. You have 2, 2, 3, 3. So this is y equals x. These are these functions. Now, y equals x squared is on the interval where x has an open circle here. So x, as long as x is to the left of this point or equal to this point, so x has to be less than or equal to, what's this point right here? 2. And this function is y is equal to x. So the other function is y is equal to x, because that is the linear identity function. And that is when x is, look right here, greater than 2. So that is when x is greater than 2. So that is a piecewise function that represents the graph in problem 17. All right, approximately what interval is f of x equal 2x cubed minus 5x squared increasing and decreasing? So this is one where having a graph will really help us. 2x cubed minus 5x squared. Not doing this on just using algebra because that's calculus. Let's do zoom standard. So let's do the standard zoom. So what's going on here? All right. So I'm actually going to zoom in. All right, and I'm going to just adjust my window so my y min becomes, I don't know, -4, so I can see a little bit better. Oh, let me adjust that even more. Change my window so my y min becomes, say, -7. Okay. So when is the function increasing and decreasing? Well, just by graphing the function. Going down forever, then you have this maximum here, and then it starts decreasing, and then you have a minimum here, and it starts increasing then. It is increasing up to this point. It is decreasing in between, and then increasing back again once it's at an inflection point. So we just need to find the coordinates of these, this maximum and this minimum. So let's find our maximum. Second, calc maximum 4. So we have, hopefully you can see that this maximum is at, so that's at 0, 0. So we have a maximum at 0, 0, 0, 0. And then we need to find the coordinates of this minimum. So second, calc, find our minimum, left bound, right bound. Find that minimum. So we're at coordinates 1.66, 1.66, -4.62. Okay, so we're at coordinates in 1.66, -4.62. And we're worried about our intervals, our x intervals. So 1.66, we can call that interval, all right? So increasing. We are increasing, once we found our intervals, we're increasing from -infinity all the way to 0, increasing, REA, increasing from -infinity to 0, and then we're decreasing from 0 to 1.66, but then we union, and we're increasing from 1.66, so that's 1 2/3, by the way, 1.666 to infinity, and we are decreasing. When we're decreasing, once we found the critical values, we're decreasing between 0, 0 and 1.66, so we're decreasing from 0, an x value of 0, to an x value of 1.66. Remember, intervals are always about what's happening to the function over the span of x values. Okay. 19. Write a statement that is true about the function's symmetry if f of x is equal to 2x cubed minus 4x. Okay, so we have f of x. Let's find f of negative x. Well, f of negative x is equal to 2 times negative x cubed minus 4 times negative x. So negative x cubed, that's negative x times negative x times negative x. So that's going to be equal to 2 times negative 1x cubed, because you have a negative number multiplied by itself 3 times is still a negative number, minus 4 times negative x, so that becomes negative minus negative 4. So simplifying this, it becomes negative 2x cubed plus 4. And this is not equal to f of x. This does not equal 2x cubed. I'm sorry, that's minus, so that's minus 4x, so plus 4x. So this is not equal to x cubed minus 4x. This is not equal f of x, so this is not even. But it could be odd, because negative f of x is just going to be equal to negative 1 times 2x cubed minus 4x. So just switch the sign. That's become negative 2x cubed plus 4x. And negative 2x cubed plus 4x does equal negative 2x cubed plus 4x. So f of negative x is equal to negative f of x. So the function is odd. You also have origin about the symmetry. You have symmetry about the origin. 2x cubed minus 4x. You have symmetry about the origin. Okay? Now, problem 20. Find the inverse of f of x is equal to 3x minus 4 over 2x plus 3. So switch the x's and the y's. X is equal to 2y minus 4 over, 3y minus 4. So my apologies. Don't miss copy problems like I do. Because if you miscopy a problem and then try to solve it correctly and then get the answer wrong because you miscopied it, that's a preventable way to get a question wrong. 3y minus 4 over 2y, over 2y plus 3. So multiply each side by 2y plus 3. You have x times 2y plus 3 is equal to 3y minus 4. Now I distribute the x. 2xy plus 3x is equal to 3y minus 4. And now my goal is to get all my y terms on the same side. So I'm going to subtract 3x on each side and add 3y on each side. So I can get 2xy plus 3y is equal to negative 3x's cancel out. Negative 3x minus 4. My last step is second last step is I factor out a y. So when I factor out a y, I do isolate a y, and I'm left over with 2x plus 3. When I'm left over with 2x plus 3, that's equal to negative 3x minus 4. And I divide each side by 2x plus 3. 2x plus 3 divided by 2x plus 3. And so now I have y is equal to negative 3x minus 4 over 2x plus 3. Negative 3x minus 4 over 2x plus 3, that is equal to the inverse of the function. The inverse of the function is equal to negative 3x minus 4 over 2x plus 3. That is the inverse. Okay, that is a full solution. Okay, wow, this is an hour and a half.